So here's just some examples of some of the techniques that I use. We use a lot of Python. Python is a programming language where you can kind of suck in large data sets and then analyze them. So this is just an example of looking at textiles, like how many of the textiles that are in the Met database are woven, are lace, are embroidered, are printed, are trimmings, are velvets. I am not a textile expert at all. I suddenly have to be a little bit of a textile expert just to look at the data and make sense of it. Also, the modeling of who created something is very complex. If you look in here, you'll see that not only do we have anonymous creators, we have anonymous British 19th century creators or anonymous French 16th century. So there's a lot of weird things we need to handle. Like we don't know the artists, but we know that they're British and it's 16th century. That vagueness is sometimes very complex to capture in Wikidata. Right? And then we also have run some stats about what percentage are public domain works that we can ingest into Wikidata. So this is our basic kind of task that we have that we do on a periodic basis. We bring in the METS content in a kind of a spreadsheet format, also known as CSV, right? Comma separated value. There is also an API or application programming interface for the MET that you can jack into. And we bring that content into one gigantic data structure and we compare it against Wikidata. So you can see that the right-hand side here, we can do a Wikidata query and then bring in all the content and then compare those two. So believe it or not, we have enough space in computer memory to bring in all 600,000 items from the Met and then all tens of thousands from the Wikidata and then compare them on a massive scale and then spit out what needs to be changed and then affect that change if we need to. We're lucky that the Met's collection, 600,000 doesn't sound small, but it's not as big as most other gigantic museum systems. So it's pretty good. It's doable that we can do this. Anything more than 1 million items at a time probably starts to get pretty cumbersome to do in one shot like this. But this is our basic workflow for how to do that. So this is one example, because I know that Shani had mentioned, like, how do we use spreadsheets in a way that's useful here? So this is an example of, like, on the left-hand side here, we have what the Met's record looks like. The Met has a record that says, there's an evening dress. It was made in 1995. Here's our object ID, and here's the designer. Now, this sounds pretty simple, like, okay, let's just put this in Wikidata. But the problem is, the object name is evening dress. So we need to check to see whether we have an object in Wikidata that correlates to evening dress. We need to make sure that the Valentina designer is in Wikidata, or we need to create that. So this is not easy. This is not trivial. Like, we need to reconcile what's in the Met database with what's in Wikidata. We employ what we call a crosswalk database. Hopefully, someone has done the work here to say, oh, evening dress, it is actually this Q number from Wikidata. And the way we model it here is that we don't have a Wikidata item for dress per se, for evening dress per se, but we do have a Wikidata item for dress, and we do have one for evening wear. So we can say that the evening dress is a dress that is also evening wear. So that's why we have 2 Q numbers there. And so when we enter this Met item into Wikidata, we enter it with 2 Q numbers for instance of, right? It's an instance of a dress, but also evening wear, and that's kind of how we've modeled that. For some things, it might make sense to say, no, we don't want 2 Q numbers, we want 1 Q number. And for some cases, that's true. But in general, for all the evening wear, we said evening blouse, evening dress, evening ensemble, evening suit. It's 2 Q numbers for the instance of. So what we do is we create this crosswalk database, right? We maintain this intermediate database like that. So then we know how to generate that. So that's quick statements. So I know that Shani wanted us to show you quick statements. This is a great example of that, where we take the record on the left-hand side from the Met. We say, oh, evening dress, that's actually 2 Q numbers. And then this is what a quick statement looks like. If you are creating a new item, you give the directive create at the very top, which is what you see here. That creates a blank Wikidata item. And you don't know what that Q number is of that new data item, but that's okay, because all you need to do is say last, meaning that, you know what, that thing you just created, just use that Q number. I don't need to know what it is, but you know what it is, Mr. Quick Statements. And then I want to add these triples or statements to it, right? So you say last P31, which is instance of, then Q21444556. Yeah, that's it. That's pretty cool, right? So that is basically saying whatever I just created, it's an instance of a dress, and it's also an instance of evening wear. And that's basically it. So all these other things, you'll notice that I'm not going to go into all the details here, but you can see that this is an English label of evening dress. You can see that this is P195. Excuse me. And that's P195, and this is a collection of the Met Museum, and it's putting in the accession number. This is a unique identifier for that item. And then we also have a description. The description in English, DEN, right, is evening dress by Valentina, Met, and here's the accession number. So this is just a great example of what a quick statement looks like to add something based on this content. Does that make sense, Shani? Any questions?
Yeah, that makes sense. I guess before we delve more into spreadsheets and stuff, can we show the students an example of how we can easily explore, like what you did for the Cleveland Museum? You created that the Jupyter notebook and all the queries in one page for people to be able to explore the collection. So
Yeah.
maybe we can quickly show something like that and then delve more into spreadsheets, etc.
Absolutely. Yeah, so let me show you what we did for both the Cleveland Museum, and the more complete version or complete example is what we have for the Met Museum. So the Met Museum is more complete. Let me show you what that looks like here. So this is the Met Museum's dashboard, as we're calling it, or open access portal. And you can see multiple tabs at the top here. So if you can, anyone can visit this at Wikidata. So it's a Wikidata:/Metropolitan Museum of Art. And what we're doing here is we're showing you some stats for all the objects that we have here. But you can also break them down by the timeline of art history. And as I mentioned, rather than every object in the Met that you can hit right here, if I click on that, you will see that this is a report on all the objects that we have. Now, the interesting thing that you'll note is that paintings is number one with 11,000. You're like, whoa, that's a lot. There's a special project in our community called Sum of All Paintings, which is an incredible project. And it's, a dozen or, I'd say 10 to 20 people are very dedicated to just focus on paintings around the world. And it's been a gigantic kind of process of incorporating as many paintings from as many GLAM institutions around the world. That's why paintings will always be much higher than anything else, regardless of the organization. Sculpture, drawings, woodcut prints, et cetera, et cetera. And what happens here, this is a tool called Integrality. And depending on whether it's interesting for your class, I'd encourage folks to play with it. It's really cool. And what you do is you put in a Sparkle query, and it will give you a report on the completeness of any of these columns. So I can basically say, show me the completeness of the image field in all the paintings, or the image field for all the sculptures or woodcut prints. So you can see here that because of copyright issues, this is not going to be 100%. In fact, it's far short of 100%. Like, there's a lot of 20th century paintings from the Met in this database in Wikidata that we just cannot do, because anything, after 1920, was it now 25, 26, we just cannot do. That's like, it's still under copyright. But a lot of the woodcut prints are very, very old. That's why we have like 99% of the woodcut prints we have an image of, because they were like 15th century, 16th century woodcut prints. They're all out of copyright. Sculpture is hard too. Sculpture, is quite modern in terms of what is at the Met. But statuettes and codices, right? Codex, that's an old-fashioned word. That's like very old. They're 100%. All 38 codexes, we have a picture of there. So this is kind of a neat way to kind of show the completeness of any of these things. Height, width, creator, the Met object ID. Now, hopefully it's 100%. Yes, it's 100% because these are all Met objects. So we have the Met object ID that's complete. And then hopefully we have at least the creator, even if it says anonymous or unknown. We have 95% of all the creators for paintings entered, which is pretty cool. So this is a report for all the objects. But if we want to go to the timeline of art history, which is like the 8,000 most prominent objects from the Met, then you can see it breaks down like this, right? That we're trying to get as complete of a accounting of the 8,000 objects here. So this is a subset of all objects here. But if you want to see them all raw, you can. This is timeline inventory. So you can go in here and you can see all the objects that are timeline of art history. So believe it or not, If you look at the scroll bar there, it is really long. This is like thousands and thousands of rows here, but you can do that, and it's pretty cool, right? You can actually see the raw records of each of these things. And this is using a tool called Listeria. This is basically doing a Wikidata query within a wiki page, and it'll just spit out the contents, not in a query.wikidata.org page, but in a real wiki page. It writes it. So I think this bot runs like once a week to create this report, which is really great. That means that people who don't know anything about Wikidata can benefit from Wikidata by seeing these reports with images and all this information here. And it's just really a great way to showcase to museum people what we have right now. And you can see all this information there. Now, if we go back to the top, you can also see the highlights. So again, this is like really the cream of the crop, the most relevant or select content from the Met. This is only about 1,500 items. So this is really the top of the top here. You can also see the inventory of those objects there. Now, if we wanted to go in and see some other tools, and this is what Shani was talking about, we can actually go in and see a open access report. So this is kind of neat. So this is actually doing a live query against Wikidata, and it's using a tool called Jupyter Notebooks. This is, I'm sorry, I'm not showing it on the screen. Let me go back and show it to you here. So this is the Met Museum Open Access Report. This is typically an interactive programming environment using Python, but in fact, we're kind of repurposing it to show you live views of what is in Wikidata. So you can see this is a live count. There's 14,000 some objects from Wikidata from the Met in Wikidata. And this is just kind of an image grid. This is a live query, right? So if any of you load this up on your computer, it'll do a live query. And you can see here, as I mentioned before, what kinds of artworks do we have? Oh yeah, it's mostly paintings because of that. Some of them all paintings. Let's get rid of paintings and see what happens if we get rid of that. So this is a breakdown if we get rid of the paintings as an outlier. So you can see it's sculpture, drawing, woodcut prints. This is a bubble chart that shows you how popular they are. This is a cool one. It says, who are the most prominent artists from the Met? This was unexpected. I did not expect that Jackson Pollock, 466 works. Now, this is also something that is a little bit misleading because I believe that Jackson Pollock, being such a prolific and modern guy, he had a lot of sketches and drawings and drafts and studies. So, and also he's a very modern guy, right? So we can't find all the studies and drawings of Leonardo da Vinci, but this guy who is fairly modern, we have lots and lots and lots of stuff from him, right? That's probably why he's up here. And you can see that even though the most popular artists in the Met are not the ones at the top here, they're pretty prominent. The most depicted things, this is quite interesting. So if we go in, we actually have depiction information for these folks. So you can see man and woman, probably not a surprise. We like to joke that in the art world, if you say, who are more depicted, men or women? Men outrank women. If you go in and see how many nude men or women, it's much more women than men. That's a weird observation, but that's typically what we see in art museums. So men, women, tree, boat, Virgin Mary, child Jesus, flower, house, horse. A lot of religious themes in here. These are things that you'll often see. When we saw the Jackson Pollock example from before, timeline of the most prominent artists. So you can actually plot these on a timeline. So these are one of the cooler things that you can do with Wikidata Query is you can take any data set, and if it has time information, you can actually plot them on a timeline with one click. So I like to show folks that just with the Wikidata Query, as long as you spit out the right column of information, Wikidata Query will graph them, chart them, timeline them in a way that makes things a lot easier, right? Here's an interesting one. You'd say the top 400 most prominent artists in the Met, where were they born? You can see still very much Western world, right? European, North American, not even South American, not even African, but Japan is actually more popular than Southeast Asia or China in this case. So, lots of Japanese prints and lots of Japanese works are in the Met collection, but prominently the most prominent are European. And that makes sense because the Met had its start with a bunch of American philanthropists who were in Europe and said, oh, we're so envious of those European museums. Let's make one of our own in New York City. And that's kind of the origins of the Met Museum. All right. So what other things can we see? Well, that's mostly it. So it's kind of cool. This is a gallery showing you. We can show you geographic information. We can show you timeline information. We can show you scale with bubble charts. We can show you galleries as well. And I think this is a nice way to display all the ways that Wikidata query is powerful. Does that answer your question, Shani?
Oh yeah, definitely. I think it's really cool, and you've mentioned depicts, so I have to have you show the students the depicts game that you created. Maybe you can say something about that and why we're actually doing Wikidata games in the first place.
Yeah. Okay. Let me go bring it up, and I hope we have candidates that are available. So one of the weird things about the Wikidata game, have you shown the Wikidata game at all before?
Well, I can. This is pre-recorded, so when the students see it, I can probably show them.
No. I mean, we can show. I just wanted to find out what assumptions we start with. We can show them the game here.
Mm-hmm.
So this is the Wikidata game, and the idea here from Magnus Mansky, who created this, was really cool. And he basically said, there's a lot of tasks in Wikidata we can do by just giving you a possible edit, and then you just say yes or no. Right? You can help us by not having to get into all the interface and just say answer yes, no, no, yes, yes, maybe, I don't know, and help us make very simple edits through a game interface, which is basically saying thumbs up, thumbs down, or I don't know. So this is what the distributed game is, and you can actually go in and do this. And let's see if we have any left here. I'm not sure we have. Oh, yes, we do. Excellent. So, the problem with this is that our community is so prolific and so productive. They've actually exhausted a lot of the games that we have here. So this is a game that I created, which is bringing up an image. And what we've done is we have fed the image into an artificial intelligence system that has been trained with MET images. And what happens here is the AI, or the artificial intelligence machine learning algorithm, has said, I think there's a mountain in here. But, I think it's very healthy that Wikipedia editors and Wikidata editors are very skeptical by just adding everything the AI thinks is there. No. We want a human to help in this process. And this is where the game is perfect. So here is a Chinese painting. Let me make it a little bit bigger. Hopefully you'll see it here. And the AI says, I think there's an image of a mountain in here. And as your volunteer, you can say, yes, it does depict a mountain in green. Or you can say, no, it does not depict. Or you can say, I don't know, and hit skip. So the cool thing is here, I can go in here and say depicts a mountain. And just by clicking that button, it has made an edit in Wikidata on my behalf, which is pretty darn cool. So let me see if it's made that edit. Yes, it has. Look at that. So let me go in and show you. So if I go to my contributions on Wikidata, go under Wikidata, hit the contributions button, you will see, hopefully, look at that. Illustration of Zhang Qi's poem and the Cold Mountain Temple. It has said the distributed game has made an edit that says claim depicts mountain. Look at that. I mean, I still think that's really cool, even though I programmed the code to do this. That by clicking a button, it makes an edit in Wikidata as complex as you're seeing right now. That this painting depicts a mountain, and you'll see that in the edit summary, we like to be as transparent as possible in the Wikidata community. And that said, the distributed game number 49, there's a bunch of games, so this is number 49, made this edit on behalf of that user, and you can actually search all of the edit histories in Wikidata for this tag to figure out and to audit whether people are playing this game appropriately. But this is pretty cool, right? This is pretty neat that, think about all the steps here. We've taken the MET paintings and data set, because the Met spent a lot of time, there's like 4 to 6 months, processing all of its paintings. It paid people to add in, does this depict a painting of a mountain, a cat, a dog? It fed all those things, at least I helped feed all those things into a machine learning algorithm. It says, here's a painting, here's what it depicts. Here's a painting, here's what it depicts. Train the machine learning algorithm. Now we can feed new images into the system. And it predicts saying, oh, I've never seen this painting before, but knowing what I know, having been trained by the MET system, I think it has a mountain. And then we as Wikimedians say, we don't want just an algorithm spitting in mountain, mountain, mountain. We want a human being in the loop. And that's what we're doing with the Wikidata game. So we're saying, human, does that have a mountain? I'm saying, I'm not sure. I think it looks like a mountain. I'm going to hit skip. Now, what about this? Yes, it does have a mountain. I say depicts a mountain. Each time I click on that, it creates a entry in Wikidata that says that painting depicts a mountain. That's pretty cool. So this is a game that we played with volunteers at the Met Museum. So we had a reception at the Met Museum at the Great Hall. One of the most famous places is where the Met Gala and all those things happen. And we had a champagne and cocktails hour where we had, museum professionals. We had the board of the Met there, and we actually had volunteers play this game, and they knew nothing about Wikidata. They didn't know what metadata was. They didn't know what a depict statement is. But we just basically said, look at this painting. Does it have a mountain? I said, yes, it does have a mountain. And we had people sipping champagne, drinking, and doing this. And it was pretty amazing that we had productive edits being done by all these folks. And it was making live Wikidata edits. Shani, is that adequately explain kind of what the Wikidata game does?
Yes, it does. And hopefully you can keep a few mountains for the students to try themselves.
And hopefully I can reload some other categories so that it's useful.
Yeah, that would be awesome. I do want them to try because it's fun, and it's not, you don't have to really go into the loop of what Wikidata is and still make a contribution. So yes, I think that's really neat. Awesome. So now that you know, students, the Wikidata games, and you understand how we can kind of use Wikidata to showcase the collection at the museum, like Andrew showed you, why don't we delve into a bit of the nitty-gritty details of how this is actually done? And I've asked Andrew to kind of show, you can show the picture of, yes.
Yeah.
Is it the picture of all the cool people at the Met reception playing the Wikidata game?
Yeah, I mean, it might be useful to show that we actually worked with Microsoft here, with Microsoft Research. They helped us ingest all that information in. And then I helped write the code that bridged the AI system that they helped us create with the Wikimedia side of things. So this is just a very complex chart showing you exactly what I just told you, is that the keywords and the images were fed into the AI system. And then we bring in new images, and it spits out some recommendations. And then this is where the Wikidata game is. Like, it's human beings looking at the image, looking at the options, and then hitting yes or no, or depicts or not depicts. And that feeds that back into Wikidata. And these are the folks playing that game, right? You just saw that right there. These are people who have no idea what Wikidata is. These are folks who are holding champagne glasses and coming up to say, what is this? I'm like, okay, look at the picture and hit a button. And, even my 8-year-old kids helped with this. That's amazing, Shani, right? If you think about it, could you imagine trying to teach an 8-year-old how to edit Wikipedia or edit Wikidata directly? But we have this game, and I had them play it for about half an hour saying, okay, kids, look at the picture, look at the buttons, and click the button that is true. And that's pretty fascinating to think that we can get kids to be productive contributors.
Yes, it is. And not only kids, this is a great way to kind of engage any visitor to any of these labs, right? Which is always something museums like to do. They want the audience to get engaged and to do cool stuff, and they can play a game and still contribute something to the collection, which is quite amazing, and help curate all that information, because it's endless. We have so much work to do to kind of make sure that the more we do it, the better results we get. So the more people involved,
right,
the better results we get. Okay.
Exactly. And I think that's where our community of Wikipedia editors and Wikidata editors, we haven't gone far enough to provide these easy or ready or more accessible ways of contributing that are lower learning curve and just fun. It's one of those things where even if you wanted to find this, it's hard to find this. So why don't we surface this kind of interaction more commonly on the Wikidata or Wikipedia interfaces? Right now, we still kind of have this very high bar to participation, saying, oh, no, you must create an account. You must learn how to do our wiki text editing and everything. So I'm a big fan of trying to be more inclusive and getting more people involved with interfaces like this.
Yes, and gamification has a really big part, I would say, in doing stuff like that with the larger audience or the public, I would say, in general. And I'm hoping actually that at some point our work in several academic institutions, especially with departments like computer science or digital humanities, will end up having Wikidata courses. And in these Wikidata courses, they will need to do projects. And hopefully some of the projects are going to be creating these cool interfaces that you described to make contribution easier. So I'm hoping this is still coming up. Not everyone can today do what you have been doing with Microsoft at the Met, but I think creating a game is not that complex. It's been done by a few, but by a bunch of people in our community, and there might be other ways to engage. So yeah, I guess we'll see. But this is more about exposing the students to the idea that it's even possible, right? And why it's important.